Okay, let's look at an option for plotting y equals x squared that doesn't involve doing a Google lookup and Mathematica help. The problem with Mathematica help is that you need to know the syntax before you can do that. You need to know, because it expects certain keywords. A natural language query is one where there's a machine out there that looks at all possible meanings and tries to pick the best meaning no matter what you've typed in there and tries to fill in the blanks and guess what you wanted to do. That is not Mathematica. That is, however, Wolfram Alpha, a companion product to Mathematica. And you can get to the Wolfram Alpha engine through Mathematica by starting out your plot with an equal. So if I were to go to the, you have to have internet access for this because it's going to go out to the Wolfram Alpha machine and try to do its best guess at what this means and come back with the Mathematica code for it. So I'm going to type in graph x squared. I probably shouldn't use the control which I usually use with Mathematica. X shift squared from -2 to 10, for instance. And if this machine gets clever, more and more clever, so it may be able to pop up a graph like that, and it does. So this is the natural language query. You could say graph it y equals x squared possibly. Range or domain from -2 to 10. It would probably still be able to parse that and figure out what you meant. But this is the this is the graph that Mathematica would make with the plot command. Now once you've got that, that's as good as looking up these commands on Google and help. And if you click in the actual Mathematica code, then you've essentially looked it up and used it, and there it is. So that's one way to kind of do a shortcut if you have access to the internet while you're doing this. Let's try graph. We may push the limits here. X squared from -2 to 2 in red, and see if it inserts the, whoa, okay, obviously my syntax was wrong. That should have been an equals graph. X squared from -2 to 2 in red. Gone out over the internet, and there we go. Plot style red. Pretty cool. Okay, how about if we wanted to plot, I'm not going to close this up because I'd like to copy that if I could, please. There we go, copy. Let's push the envelope here, paste. Graph x squared and sine x, and in red and green. Oh, and again, I don't do it this way very often. I usually use the palettes. Equals, enter. You know, make lots of mistakes, figure out what you're doing wrong, correct them. That's how you learn. It's taking it longer. I don't know if it's going to be able to do this. Probably if I can't do it now, in a year it probably will be able to do it because they're constantly improving it. And this little dark brace over here is telling you that it's still working, it's still working, it's still thinking, it's still trying to figure out what you meant, and it's trying to return no available interpretation. So, oh well, you know, whatever. It couldn't figure out what that was. It exceeded the time they wanted to spend looking at that for free. So, but I'll bet, how about this? How about if we delete this? Enter. There, got it. Okay, so now I can probably guess how to get the red and green on there if I were to type let me collapse this to just Mathematica code because I think I have an idea what to do here. And how about we pop back in the palette and say style. Oh, look, here's a style if there's more than one thing. I'm going to put a template in there for that. And I'm going to say red dash, and you better use the capital D, dashed green dotted yellow dotted D-O-T dotted. What I suspect is going to happen is it should apply the red dash to the first one in the list of graphs and the second plot style to the second item in the list of graphs. And you have to use Shift Enter if you're on a laptop, or if you're on a desktop you can use the numeric pad Enter. There you go. Done and done. Very powerful, very easy to learn to use if you just get your head in the right spot and get interested in experimenting around with this. It's much more powerful than the graphing calculator you probably were using, and it's more powerful than Wolfram Alpha because you can create entire documents, you can create textbooks if you want to out of this. Okay, we'll take another stop here and see if there's anything else we need to do.